We're going to build this visualization of the solar system, where each planet is introduced and labeled individually with these nice transitions. Let's visualize the solar system. I've always been intrigued by visualizations of the solar system because they're always distorted in some way. It says here size to scale, distances not to scale. Why is that? I found this list of objects in the solar system which has a table here. This has the radius and also distance from the sun for the various planets. I would like to modify this example to represent the solar system. I'll start by forking this viz and calling it solar system. This data here is going to represent the planets. So instead of ID, I'm going to give each of these a name. I guess we should include the sun. And instead of x, this will be distance from the sun. And since it's the sun, the distance is 0. I'm not going to include y because they're all going to be aligned horizontally. And the radius is going to be the actual radius of the body from this data here. Actually, the sun's not included here. But on the page for the sun, it has some information about the equatorial radius, which is 109 times whatever the Earth's radius is. So I'll use that, 109 times Earth radius. And what's Earth radius? Oh, it's listed here as 1. Okay, I guess this E unit is in terms of Earth radius. So the radius of the sun is just 109 in terms of Earth radius. Okay, and then let's pick a color for the sun. This orange is okay. And then I'll delete the rest of this and fill in the data for the rest of these planets. So let's start with Mercury. I'll set the name to Mercury. And I'll set the distance from the sun in AU, astronomical units, where 1 AU is the distance between the sun and the Earth. So I'll copy this number here, 0.387. And then I'll copy this number here for the radius. And then what color is Mercury? It looks like kind of gray. So I'll pick a gray color. And let me set the background to be black, because we are in space after all. And I wonder if the AI would be smart enough to fill in the data for the rest of the planets here. Oh, it's doing a decent job. All right, Venus, Earth, and it's even picking colors. Wow. Mars, Jupiter, wow, Saturn, Uranus. Now this is the AI powered by GPT-4 filling in this data for us. And it stopped at Pluto. Amazing. Now let me just verify these real quick. Venus, 0.72, yep. Radius, 0.9499, 0.9488. Well, that's close enough, I guess. Earth is 1, yep. Mars, distance is 1.5. That looks right. It must have used a different data source. The numbers are pretty close, but I'm just going through and pasting the exact values. Okay, now that we have this data, let's visualize it. As the ID function, I'll use the name instead of the ID. And since we have CX and CY duplicated in 2 places, I'm going to define these in a single place. I'll call it x value, and the x value will be a function that uses the distance property. But this is in astronomical units, and we need it in units of pixels. So I'm just going to hard code a certain value here, which is, I'll call it a scaling factor, that we can tweak to make it show up in the right spot on the screen. And for the y value, I want to just put them all in the middle. So this won't even be a function. This will just be height over 2. And now we can use x value and y value wherever we define cx and cy, namely in the enter and also in the update. And the old code uses d.r, but we need to use d.radius. But actually, since there will be a scaling factor applied, let me pull this out to a function called r_value, the radius value. And this will return d.radius times some number again. Okay, so after refreshing the page, this actually works. But we're getting things that are proportionally out of whack. They're way too big. But that's all right. Let's just tweak our scaling factor. Oh, it's not updating because we need to also set the radius in the update part. Okay, now it's working. Okay, so as I scale this up and down, we can see that the scale of these planets changes. But look at the sun. The sun is way, way bigger. Way bigger than everything else. So let me get more resolution here by dividing by 100. That way I can scale it. More of a fine grain. Okay, well, this is good information. The sun is massive compared to all the planets. And that's sort of expected, but here we get to really see the relative scale of this. Okay, well, what do we do now? In this diagram in Wikipedia, what they do is they put the sun like this off the screen so you can just see sort of the edge of it. I guess we can try something like that. And what about the distances? Are we even seeing all the planets? No, we're not. See, there it is. There's Pluto way over there. Okay, well, this is why it's always so difficult to visualize the solar system. Because if you visualize it to scale, you know, the distances are so vast and the sizes are so different. I bet it would look something like this, where you can't even see the planets. So, I don't know, how should we handle this? Maybe I'll just move the sun over? Seems a little sketchy, but I guess we could do that. We could special case the sun in our x value. We can check that the name equals sun, and then do something special. Is the name equal to sun? If so, we can hard code it to be like, I don't know, minus 100. Otherwise, we use the regular distance. So now we get control over just moving the sun. And I'll move it over to the side so that we can just see the edge of it like this. And then let's push over everything else by adding a constant. There we go. Now we can tweak it so everything is just like that. But again, we're introducing some distortion to the visualization, which I don't really like, but I'm not sure we have a choice here. And I guess we could tweak the radius so that we don't have overlapping planets. Yeah, that feels better in a way. Then we can bring the sun back. And we've got the opacity left over from before. You know, we can set the opacity to 1, in which case we can just delete that line that sets the opacity. And now I would kind of like to add labels to this, but I know it's going to get pretty gnarly because there's going to be overlaps, but we can try anyway. And it would be so cool if we could have it so that when the page loads, the planets kind of come into view one at a time. So there's the sun, there's these inner planets sort of popping into existence. It would be so cool to get the labels to appear at the same time as these. So let's give it a shot. I'm going to copy paste this whole block. And then instead of selecting circle elements, I'll select text elements. And SVG text elements, that's what lets you write text. And these text elements have X and Y. There's no concept of R. But what we could do actually is have them fade in by setting the opacity to 0 initially, and then setting the opacity to transition to 1 once they emerge. But in order to see anything, we have to set the text value to be a function that takes as input d and then returns d.name. And in the spirit of making these things abstract, I'm going to call this label value, and I'll define it up here along with x value, y value, and r value. So there it is. Label value is a function that returns d.name. And in the update selection, we can just set x and y. And then when we exit, we can set opacity to 0. And you know, the fill of these labels should always, I think, be white. I think I would just like to make them white so we can see them. If I refresh the page, there we get the labels. They're showing up. Okay, Jupiter, Saturn, Uranus, Neptune, and Pluto. All right, now we're getting somewhere. I want these to appear below these planets and centered. And I also want to use a different font. So I'll start by setting the font by saying .style font-family sans-serif. And because this is on enter, I'll need to refresh everything here. So now the labels appear in a different font. That's great. And you know, just so this works with hot reloading, I'm going to put this on the merged enter and update selection, so I don't have to keep doing that. Okay, so there's a certain property to align the text horizontally, but I don't remember what it is. Let me see if the AI knows. Okay, yeah, text anchor middle, that's it. So now they're in the middle, and then I want them to be hanging off of the bottom of these planets. I believe the attribute name is alignment baseline. Hanging. Yeah, there we go. So now they're hanging below the center points. But, you know, instead of the center points, it really should be the center point of the planet plus the radius plus some additional gap. So instead of y value, I'm going to call this y value, rather y label value. And we'll define y label value to be r value of d. And that's not quite right. We need to add y value, which is a constant. And now they're positioned relatively correctly. Let's just add a bit of space. I'll just hard code it to be, let's say, 5. Okay, that's great. Now we just need to fix a couple of cases. Pluto is one of them. That's a pretty easy fix because we can just scale it back. We can multiply the distance by a slightly smaller number. Now Pluto looks good, but these inner planets, the labels are all sort of tied together here. So what I'm thinking is that Earth, because that's our planet, that can stay close to the circle. But these other ones can move down a little bit. Let's start by moving the label for Venus down a little bit. Or, you know what? We could put that into the data. Yeah, I like that idea. Label offset. This can be like 10 pixels. And then we can leverage this value in the accessor. So yeah, let me move this definition up with all these other value accessors. That's what these are called, by the way, value accessors. Functions that take as input a data element and then they return some kind of a transformed value into pixel space so that you can put it on the screen. So we want to leverage this label offset property, if it exists, for this y label value. So we can say plus d dot label offset. You know, does it exist? If so, we add it Otherwise, we can just ignore it and add 0. Okay, that failed. Is it just a parentheses issue? Yeah, there it is. Okay, now Venus is a little bit further down. Sweet. So let's do the same for these other planets. Mercury is going to get a label offset, and I'll just move it a little bit further down. And then Mars also gets a label offset. And maybe this one can be negative, so it's right up there. Okay, this is looking pretty good. I'll just tweak Venus so it doesn't overlap with Earth. And then tweak Mercury a little bit. You know, Mercury might be better suited up here, actually. And that M is overlapping with the Sun. So let me just pull the Sun over a little bit. I don't know. I don't really like how that reads. I kind of want it to read top to bottom, left to right. Because this is a little confusing to read. So let me make Mercury first, then Venus, then Earth, then Mars. Okay. That looks better. All right. That's how we can visualize the solar system. To recap what we did here, we changed the background to be black. We changed the data so that each of these objects in the array represents a planet that has a name, distance from the sun in astronomical units, and radius in astronomical units, and a fill. Then we set up these value accessors so that we can tweak the distance easily like this. And we added a special case for the sun to just move the sun off the screen there because it's so huge compared to the other planets. I mean, it's not even a planet, it's the sun. Then we set up this radius accessor so we can tweak the scaling factor here. And we defined the label value, which uses the radius plus this y value, which is height over 2, the center, plus 5, which is this little bit of spacing there. And then, if there's a label offset on the data, then we use it. And we defined label value to be a function that returns the name. And it occurs to me that we could use that here as well to make all our D3 code pretty generic. And then we're using the same setup as we had before for the circles. Yeah, that's all pretty much exactly the same as it was. And then we introduced a section for the text that transitions the opacity instead of the radius. And we use Y label value to position these. And we set up some styling to set the font family, the text anchor middle to center it horizontally, and then the alignment baseline to specify that it hangs to the bottom of the coordinates that we specify. And remember, the original purpose of the transitions is to get this cool effect. So let's see what happens when we refresh the page. These things appear one by one: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. All right, that's how you can visualize the solar system. And I'm just going to fill in the README here saying a visualization of the solar system, data from Wikipedia, and I added the link there. But also, I'd like to leave you with a challenge. Option A, use this template to visualize the relative size of various numbers. So you can think of some other data that you can represent with size. And you can use this template to pull in the labels and size them relative to the numbers. And you might want to square root the values just so that the area is proportional to the values if you do option A. Or option B, add SVG gradients to this example to make the planets look more planet-like. And I linked here to the documentation for gradients in SVG. There's a concept of a radial gradient that looks something like this. And I bet if you add radial gradients to the planets, they're going to look awesome. Good luck, and thanks for watching.